we're going to go over the Colang language and things that you can do with it. So by default, this is going to be all the examples in the synthesis example that's provided with the container. So we can go into the examples and get a list of everything that's in here, and then we can try to run one of these. So for example, we could try to run print starcase.colang, and what that's going to do is whatever number we type in, that's how many steps it's going to print. So for example, I'm going to type in 7 and it'll print 7 steps here. And what that program looks like is like this. It's just a simple language with loops, variables, assignment statements, just to do things like this. So that's Colang, but the special thing with Colang is that it has synthesis and evaluation built into the language. So if we go back and we cd into that synthesis example, and we can just do a quick ls here, and let me show what this broken perform factorial.colang is. This is just a simple program that's supposed to take the factorial of a number, and here we can kind of see something's going to be off here because we're not incrementing I, and this doesn't seem to be the right code to do this. So what we could do is we can run the evaluation command and attempt to evaluate this and see whether it returns true or false. If it returns true, that means the program is working correctly against a set of test cases, and if it returns false, it's not. And these test cases are in this test directory here. The interesting thing about this is that we can also try to synthesize repairs to our program. So by doing the same command again, but with the synthesis argument, what this will attempt to do is it'll attempt to find a solution based on all those boundary case fixes. So here it's found 135 possible fixes, and what it's going to try to do is evaluate every one of those potential fixes against the test suite and see if it's the correct solution. And you'll see some of these take longer than the others, and that's because of the way the fix is created. But for this particular solution, I believe it happens at fix 80 where it finds the correct solution. And once it does, it prints out all the steps it took to make that solution work, as well as what the code looks like. So here we see that it found the fixes of replacing the second and fifth invocation of the variable I, and then this is the solution code here. So now we see this is correctly incrementing, and this is the correct condition for that while loop.